Respiratory exam, let's start the review. There will be, there's 50 questions, so it's not too bad. About 2/3 of them are pretty straightforward and easy. Then another probably 5 to 7 or you'll have to read them twice, and then there's 5 they'll make you really understand what you're doing and see where you're at with things like affinity and acidity and temperatures and some of those things. But I'll go through it. We'll start out with a practical portion. The practical portion are the slides and the 2 models. So I'll have the 2 models in back, and this is for the people who have never had me before, how we do it. You'll come in and sit down. I'll give you the test. I'll give you the Scantron. You'll read a few things on the board that I want you to do. I'll have the 2 models in back. All right. We'll start the exam with a picture just like this, and I'll have you have a fill-in section on the back of your Scantron, and I'll go. This is number 51. We'll start here. We'll take the practical up on the screen as a group. Once I go through the slides and you answer my questions, I'll say, okay, you can begin your test. And there's 2 stations in back that are that have these 2 models, and they're tagged back there. And you'll go back and it'll say identify the structure at the tip of the pointers, and you'll look for 2 or 3 tags on each model, and you'll have to answer those on your Scantron sheet. And we'll start over here probably on Monday, and we'll rotate back, and I'll let you know Liz, when it's your turn. And Demi, I'll let you know when it's your turn, and we'll finish up when Kylie's done. I'll say you can go back to the practical if you need to, but we go in a systematic order, so if the person next to you or in front of you gets up, you're on deck, and that means you kind of have to pay attention. There's only 2 stations. It'll go super fast. Sounds a little distracting with people getting up and down, and it never has been, never been a problem in here. And it's not timed. You have as much time as you want, but be reasonable. There's other people waiting to get back to the practical, but by the time the exam is done and everything's done, everybody's been through the practical and we've gone through all these slides, and then you'll just turn in the exam. I don't lecture after tests ever. You won't listen to me because you want to go out there and talk about how bad the questions were, or how hard the questions were, or how easy a test it was. Let's start up here. All right, listen to my questions carefully so that you will answer them correctly on the exam. Identify the organ seen in this slide. Trachea. Trachea is the organ seen in this slide. Identify the tissue at the tip of the pointer. Hyaline cartilage. Hyaline cartilage is the tissue. Identify the cell type. This is all histology. You actually have had this on your previous tests in A&P. Identify the cell type you would see with this tissue. Chondrocyte or chondroblast. Either one is acceptable. We good with that? Good. Identify this tissue. Pseudo. Stratified. Ciliated columnar. Pseudo-wispan. Identify this cell. Goblet cell. Creating mucus. Mucus. Here is the cilia on the outside. Good. Identify this tissue. Dense. Perfect. I'll accept dense. Dense, regular, connective tissue. Or dense, irregular. Actually accept either for that. Good. Easy peasy. Identify this organ. Organ. I would start off with something that's going to anchor you guys. What organ are we in? Lung. Easy. Lung. Okay, good. What is this structure?
Bronchi.
Bronchi. Bronchi. What?
Because the hyaline cartilage.
Has hyaline cartilage next to it. And if you see the hyaline cartilage next to it, which keeps the vacuum hose open, we call it a bronchi. It does look like a bronchiole, but you have to look for the cartilage on the outside. Identify this specific structure. Alveolus. L-U-S. I accept alveoli, but understand alveoli is plural. Alveolus is singular. Are we good? Now I'll throw a curveball. Name 2 cells that you would find lining this structure.
Simple squamous.
simple squamous, and type 1 cells and type 2 cells. Type 1, simple squamous, type 2, cuboidal, that produces blank. Surfactant. Surfactant. Jason?
Is type 1 and type 2 cells okay?
Yes. Yes.
So type
We would
one.
also accept simple squamous and cuboidal. PO2.
PO2 is
In the lungs?
104.
104. Gets half credit. Why?
Oh, because it's not milliliters of mercury.
You have to put MMHG. In this class, you have to put always put your values down, your variables toward that value. So 104 mmHg is a fully correct answer for CO2. We good? Do I need to say that again for new students? If you put a number down and do not put the variable after it, you will only get half credit in this one.
So that's the alveolus. The type 1 are the simple squamous and type 2 are the surfactants, if you didn't say.
Correct. Good. Structure.
Bronchiole.
Bronchiole. Don't see any hyaline cartilage around this.
I have a question about that, because I'm actually having a hard time with the histology slides with this in particular.
Uh-huh.
Because that looks a lot like hyaline cartilage.
Where's that?
Well, it's purple, it kind of has all those lacuna, or those, they look like chondrocytes.
Oh, over here?
It's kind of translucent. Yeah, all of what you're touching right now kind of
I'm
looks like
seeing
hyaline
all of
cartilage.
this as dense irregular connective tissue.
Okay.
Yeah. I'm not gonna be tricky, Jason. Do you see this?
Yes,
And is that hyaline cartilage?
yes.
Yeah, that's an automatic. If you can't say, oh, that's hyaline cartilage, then it's not. Everything else around that other cell is this dense irregular connective tissue.
Now, I don't know if I know that it's
Got that on camera.
hyaline cartilage because I recognize that slide,
Got it?
but I mean, it still looks a lot like the dense, the connective tissue.
I think it's that
Here.
big lump on the left that's confusing.
Or like the
Yeah.
kind
Kind of
So
looks
looking at
like.
that,
Kind of
Yeah.
looks like Highland, yeah.
yeah, kinda does. Kinda isn't. I guess my only suggestion to you is, it's kinda like when we did the slides you remember basophils last term? I told you, if you can't say, wow, look at those black granules, then you need to go in a different direction, because they're there in basophils. So let's just say I'll be fair and give you a nice chunk of hyaline cartilage if I want bronchi. And if you're going, well, kinda might be, maybe, then it ain't. We good? That's all I can offer. Yeah,
Is the hyaline cartilage always gonna be like in a sac like that,
Yeah.
kind of?
yeah. Remember, they're rings. They don't go completely around it, but when we get the bronchial, they're kind of a C-shaped squiggly that goes in this kind of a twisting motion, so you'll only see part of it.
Okay.
You won't see it all the way around it. It's a good clarifier as well. Understanding emphysema in normal tissue. Would you guess this is emphysemic or normal? Emphysemic, yes, emphysema. Because although this is a good, you might go, well, there's a good alveoli right there, that looks pretty good. The rest of them are all blown up. And that's what you get with emphysema. It lowers the surface area for exchange. If if I told you this cell, where are we again? Organs, lungs. This structure here is a alveoli or lus. If I told you this was a dust cell, what is its function?
It's a macrophage.
Macrophage. Macrophage. Oh, where'd that come from? Your notes. Your notes. Organ. Trachea. Tissue lining the trachea. Pseudo. C-shaped structure here. Hyaline cartilage. Good. That's all a lot. Right up in there. Ooh, that's pretty. Pseudostratified.
And goblet?
And goblets. Boom, boom, boom. Boom. Good. All right, so as I go through today, I just took the test, so I'm thinking about questions. I got my cheat sheet here. You'll hear most of them today. Really, the problem area is gonna be on this one. I don't think it's that hard. It's 50 questions plus the practical, so it's really kind of, it's a one chapter test. The problems always that come up on this exam have to do with the gas laws, the affinity issue with hemoglobin and oxygen, and the triggering for breathing, respiration, which is always CO2, all right? The one I'll give you, oh dang, first question. I don't remember.
The pons and medulla?
Pons medulla, I told you that already, that's right, that's right. The two nervous system structures that regulate respirations are the pons and medulla, thank you. So we all start with an A. The big thing is the gas laws, the CO2, we finished up in here Monday with hyper and hypocapnia. There's a challenging question on the differences of CO2 levels. So those are where people have trouble. I'll try to explain as we go through today. Basic anatomy out here. A few people have been in my office lately and have been asking me about understanding the partial pressures. And partial pressures is a tough one. It's a tough part of this exam. This picture is not a bad one because it kind of indicates, if I put a pointer out here and said, what's the PO2?
140
millimeters of mercury.
760.
But see, this is why we get problematic, because it is 21% of atmospheric. What are we assuming is atmospheric for this day? 760. Let's just start with that. All right, 760 millimeters of mercury is atmospheric pressure we're assuming in this classroom. All right, we're on the beach in Maui today. That's about what it would be. And so 21% of out here in atmosphere is oxygen, which makes it 160 millimeters of mercury in the atmosphere is made up of oxygen. What's the majority made up of out here in the atmosphere? Nitrogen. Somebody give me a number for PN2. 79% of 760 is about 597 millimeters of mercury, PN2. It's on the test, write it down. I'm not talking about anything today that's not on the test. PN2, that's partial pressure of nitrogen gas in the air, is 597 millimeters of mercury. That's out here. So we come through here, there's a question on which of the following is not a function of the nasal cavity. Does it cleanse the air?
Yes.
Yeah. Does it warm and humidify?
Yes.
Is it a passageway for airflow?
Yeah.
Yep. Nothing tricky, all right, nothing tricky. Does it initiate the gag reflex? No. There's your answer. I'm just giving them away today, all right? Is that a tough question? I gave that one away because last year I used that question and some people were like, you never talked about that. Here's your trick. If I haven't talked about it, don't answer it. There are two answers on this exam. They use a molecule, a chemical molecule in the respiratory system called BPG. You guys ever heard of it?
Yes.
Biphosphoglutamate, all right? Fascinating, the way it affects red blood cells. Have I ever talked about it?
No.
No, it's used in two answers because it is relevant, but it's not the right answers. So if I haven't talked about it, don't do that. I've never told you the nasal cavity initiates the gag reflex. There is one structure up here that does initiate the gag reflex. Anybody know what it was?
Uvula.
Uvula. Good. That's the one that I want you to know for the gag reflex. And that's the one I talked about. Good. Generally don't put anything on the tonsils, because we covered those again in digestive and we already covered them in immune system. We come down here to the trachea. We already have to look at a slide of the trachea. We look at primary bronchi. Could you label this basic structure if it was a picture on the test? Good, because you'll need to, because there's a picture of the test of basic respiratory gross anatomy, and you'll have to label the structure. Can you find the larynx on this? Can you find the trachea? Oropharynx? Nasal cavity? Primary bronchi? What would follow primary bronchi? Secondary to tertiary. Gross anatomy of the respiratory system, kind of important for this exam. So I put a picture like this on the test and you'll have to label. Good. Diaphragm, what type of muscle? Skeletal muscle, innervated by what nerve? Phrenic. And two structures in the spinal cord that spontaneously depolarize to regulate its function. Oh, pons and medulla. First question on the test. Pons and medulla are two structures of the spinal cord proper, although it's up by the brain, that regulate the function of the diaphragm. Does that look familiar? There's your model. Make sure you know the structures on the mid-sagittal model. This is an exact picture of the mid-sagittal model. Like I told you, I don't put tonsils on it. You don't have to worry about that. But the rest of the things labeled on Moodle for this model are fair game, identify structure only. Thyroid cartilage, you'll need to know. Laryngeal prominence, you'll need to know. Nothing on vocal folds or vocal cords. Beautiful picture of the trachea and the pseudostratified, which I showed you this morning already. Terminal bronchial. You should know the pathway. If your little oxygen molecule out in the air, I breathe you in, you go through my nose, you go through the structures of my pharynx, you go through the larynx, you go to the trachea, and now you're on a super pathway down the trachea to the primary, secondary, tertiary bronchi, terminal bronchioles, alveolar ducts, respiratory bronchioles, alveolar ducts. The alveolar sac is the collection. You asked me that on Monday, Tim. Alveolar sacs are these great clusters down here, and an alveolus is a structure down at the end. You gotta be able to list out the structures that an oxygen molecule could see as it moves through. Ooh, I like this one. I like this one. That's your type 1 cells. We talked about it this morning. Your type 2 cells. Type 2 cells make surfactant. Surfactant does what? It's on the test. Everything that I talk about is on the test. Surfactant, do you understand it? Lower surface tension of water, which means it lowers the cohesiveness or attractiveness of water molecules to each other, and therefore allows out a thin film of fluid around the inside of the alveolus as opposed to a big clump or glob of water in one location. Very important. Does that increase or decrease compliance when you have surfactant?
decreases? Compliance. Compliance is the ease of which we can expand the lungs or exchange of gases. Compliance, write it down. That's the tough question. There's 5 tough questions on this test. I think one of them has to do with factors that influence compliance. If you don't know what compliance is, it's gonna be tough. You need to know the factors that contribute to compliance.
What is compliance, can you say it again?
What was the question, Denny?
Compliance?
Compliance, lung compliance, the ease of which the lungs can be expanded for exchange of gases. Someone breaks their ribs, would that increase or decrease compliance?
Decrease.
Decrease, tough. Tough to change the volume size. So that's how compliance works. Just means normal lung function, really. There's our dust cell or macrophage. If you didn't know where that question came from on the practical, I said I had pointed to it and said if I told you this was a dust cell, you would tell me the function is macrophagic. Good. What's the PO2 in this structure? 104. mmHg, thank you. How about the PCO2 in this structure?
40.
40. Now we come over here to the red blood cell. What's the PO2 before exchange? There's a section on the exam where I need to kind of make sure that's clear. This means that this blood cell is coming back in the venous return system. It's come through the right atrium, right ventricle, pulmonary arteries, and out to the lungs. We have not quite exchanged yet. I put a BE after it, before exchange. So that means this is venous blood coming back. It is oxygen poor, and the PO2 is blank. 40 mmHg, 40, all right? 104 here. Because why I say that is that if this is after exchange with the lungs, what's the PO2? 104. Very good, because oxygen is moved in. So if you see a BE, that means before exchange, and an AE is after exchange, so you can understand the difference. This is on the exam. This is called the respiratory membrane. It's made up of 2 layers of simple squamous and a basal lamina. 2 layers of simple squamous and a basal lamina. 1 layer of simple squamous is the type 1 cells of the alveoli. The other layer of simple squamous are called endothelial cells that line the blood vessel. Endothelial cells and type 1 cell, plus their basement membrane called the basal lamina, make up the respiratory membrane exchange site. All right. Pressures. 3 main pressures I need you to know. Atmospheric, and we assume that we're talking about 760 mmHg. We good on that? Intrapleural. So you can draw a line in your notes here and say, now we're on to pressures. Intrapleural pressure, 756 mmHg, which is a negative pressure. Yes?
Didn't we also talk about it being 758?
We talked about 758 is the pressure when the diaphragm contracts, and the intrapulmonary pressure will go to 758.
But what about a negative number? Can we talk about a negative?
-4.
Oh, okay.
It's good. So put intrapleural pressure, 756 mmHg. It is a negative pressure. It is a negative pressure. This negative pressure keeps the lungs expanded to the thoracic cavity wall. It aids in compliance, this negative pressure. If someone is punctured with a stab wound, knife wound, this intrapleural pressure equilibrates with atmospheric and becomes 760. What happens to that lung? It collapses because we no longer have a negative pressure in the intrapleural space. That negative pressure keeps those lungs expanded. Comparatively, if someone has to be given CPR, we blow air into the trachea and out into the lungs. That is called a positive pressure. A pressure higher from the outside is blown in to a lower pressure. That's called positive pressure. Intrapleural pressure is referred to as a negative pressure. The third pressure you should be aware of, atmospheric, intrapleural, and intrapulmonary, is the pressure in the lungs, which at rest is equivalent to atmospheric.
You said because the pressure in the lung at rest is equivalent to atmospheric?
That's correct. It will help you to know parietal and visceral pleura as terms. I did a sheep blood dissection in here last week. I pointed out on the outside of the lungs, which pleural layer was that? Visceral. Visceral means organ. Means organ. So if it's directly attached to the organ, that was the visceral pleura that was on the outside of the lungs. Was that kind of a cool dissection? Students always like that. See those lungs at play, get it, touch it, feel it. It's amazing what that looks like. Good.
So the other one, parietal, so visceral pleural is on the outside of the lung.
Yep.
Parietal.
Parietal is lining the thoracic cavity. What's in between the visceral and parietal pleura?
Serous fluid.
Serous fluid, which is called pleural fluid. That allows the lungs to expand, not really to expand, it doesn't contract, but it recoil due to elasticity without friction, just like we had pericardial fluid. Heather, I didn't want to leave that comment you made alone, because there is a 758, 759, all right? So what happens is, this is on the test, good she brought it up. You guys remember Boyle's law? Somehow I made the test, makes a lot. Boyle's law, B1 equals B2, B2. Thoracic cavity. Atmospheric pressure. So you guys don't get mad at me. Diaphragm contracted or relaxed here?
Relaxed.
Relaxed. When? Michelle, when? We're in this relaxed state. Atmospheric pressure and intrapulmonary pressure are the same. That's what we just wrote down. We good on that? Then, so we got volume 1, pressure 1. Now the diaphragm contracts. We have volume 2. Is it bigger or smaller?
Bigger.
Yeah, volume 2 went up. What's that do to pressure inside? Well, Volume up, pressure down, they're inverse correlation, right? Volume goes up, pressure goes down. Give me a number.
758.
There you go. 758, as the pressure went down. They're gonna move in or out.
Yeah.
Why does air move in? When the diaphragm contracts. High to low. All we did was change the pressure, name that pressure, intrapleural, atmospheric, or interpulmonary. Interpulmonary pressure dropped simply 1 to 2 millimeters of mercury because of the change in the diaphragm, made the pressure in here lower, and air rushes in. It's called an inspiration. Good? That's what this chart means. In your textbook, if you looked at it. Here's 0, which is 760. They drop down. Boy, it only dropped 1 here. Is that okay? Yeah, I said 759, 758 is fine. 1 or 2 drops down. Intrapleural pressure is always negative. So when these are dropping down, here's what happens with intrapleural. Normally down 4 millimeters of mercury. Intrapleural is always a negative pressure, unless you have a stab wound or some type of wound in there. How much air moves in on this breath? About 500 milliliters. That is called a blank. Tidal volume. Good, you did the lap. You know what that's all about now. It's called tidal volume. Jimmy?
So when the diaphragm relaxes, does the pressure not go up to 762?
Yep, it does. Next stage. Nope, don't like that. Comes back down. Basically can call this P3V3. Volume went down substantially now. What happens to the pressure inside? If volume goes down, P3 goes up. Give me a number.
762.
762. We still in Maui? Yep. Atmospheric's not changing. All right. Now, diaphragm, relax, squeeze the volume tight. They squeeze in a balloon, air's gonna wanna get out. 762 to 760, that's called an expiration. Simply by the diaphragm, contract, relax, contract, relax. Changing the pressure, changing the volume, which changes the pressure. That's good stuff. Resistance to airflow. There's your equation. Want to keep airflow about the same if you can. Sometimes you get resistance in the medium-sized bronchi because of increased mucus buildup, and then it drops off dramatically as we get out into the breathing zones at the end of the bronchioles. 2 chemicals I talked about, you better write them down, it's on the test. Epinephrine and histamine. Which one is the vasodilator of the respiratory system?
Epinephrine.
Good, epinephrine. All right, draw another line. We got through the pressures there. Put a spirogram on the test. Everybody recognize a spirogram up here? Spirogram is a picture of lung volumes. It's used in pulmonary function tests. There it is. Extra credit, I'm going to give you one more bonus on the wall. It's a calculating an ABR. If you can calculate an ABR, you get extra credit. ABR calculation is in your notes. Okay? a picture of this, you have to label it. So if I put a pointer on this right here, you'd label tidal volume. Easy. Inspiratory reserve volume after an exhalation. Be careful you understand this well. After a normal exhalation, you take in a whole bunch of air. That's inspiratory reserve volume. I would know these numbers because these are the ones I used on the exam. I really like this one. Apparently it came up twice on the exam. The vital capacity and a normal vital capacity, we're assuming normal, 4,800 mils. That's the total amount of exchangeable air. So know what a spirogram is, be able to label the waves on the spirogram and be able to give me estimated values of a normal patient. What's the type of air that we can never get rid of? What's that called? Residual volume. Residual volume. So these are, I consider these the easy ones on the test. If I ask you a normal tidal volume is blank and gave you 4 numbers, could you tell me it's 500? Or 30, I hope you wouldn't check 3,100 or 4,800. All right? If you were here and did that lab, you good. How about this stuff? Last page of the test. I don't want there ever to be, you're like, oh my God, I never looked at it that way. So, let me just show you how I did it. How to figure out PO2s and comparatives. If I say PO2 in alveolus, there you go. That might even be the first one. 2 columns with a bunch of scenarios in them. You have to come up with a number and then compare them. What's the PO2 in the alveolus?
104.
104. We don't have to do MMHGs now. We're good. PO2 in the tissue before exchange.
40.
All you gotta do is look over there. Less than 40, or 40 is fine. See how you work this out? If A column is greater, answer A. If B column is greater, answer B. If they're equivalent, answer C. What's the answer to this question? Hey. 104 is greater than 40. We all agree on that? Want to do another one?
Yeah, I don't get what you mean if it's
This number. I give you the text. You have to figure out the number in your head or with your drawing picture, and I gave you blank pages on the back. They 3-hole punched our exam, which I find hysterical. I don't know why. So your exams are 3-hole punch. So I can take them and put them in a binder or something. You come up with the numbers, Debbie. 104 here, column B is 40. If column A is greater, you'll answer A. If column B is greater, you'll answer B. If they're equivalent, 104, 104, you'll answer C. Are we good? Okay. You're on your own. A, B, or C.
what is
Atmosphere?
PCO2 in atmosphere, ATMS. PCO2 in the alveolus.
40.
A, B, or C?
B.
B. Because atmospheric CO2 is 0.3 versus 40 in the alveolus. Are we good?
More?
More?
Can do a couple more?
Let's do one more.
Yeah.
I'm just making it up. You guys make one up. PO2 in the
Tissue.
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 Beautiful. PO2 in the tissue. PCO2 in venous return blood. Can you see it? PO2 in the tissue. 40. PCO2 in venous return blood.
45.
45. The answer is B. We good on that? You gotta know these numbers. You gotta know these numbers. Gotta be able to draw it and understand it. You can memorize them. But if you really understand it, it completely is gonna make sense to you about why this has a PO2 of 104 and blood leaving the tissue has a PO2 of 40. Because we left it here. And when you unload oxygen here, you're not gonna leave with it, or not with a lot of it. How many do we normally unload?
One.
How many oxygens do we normally unload? One. Factors that contribute to unloading 2.
Acidity and temperature.
Temperature and pH. What's the big one? Temperature. Write that down, test question. The biggest factor for unloading, decreasing the affinity of hemoglobin and oxygen, is body temperature. The other factor that contributes is increasing acidity. Science has done a very poor job with pH. Because when I say increase acidity, and when I say increase pH, do you think acidity or alkalinity? You look at numbers. Normally, the pH scale is set up like this. Neutral, acid, base. And the way we run our lives, if we say something is increasing, doesn't that usually mean more if you're increasing the amount of money you have in your wallet? Doesn't that mean more? But when they say increasing pH in science, that means it's becoming more acidic, which means the numbers are going down. Not a worry for you if you're going, wait a minute. I always put on the test, increase acidity or increase alkalinity, so you know which way we're going. Is that clear? All right, so I will say decrease pH, but in parentheses after that, I actually write acidosis, meaning becoming more acidic. Is that fair? So you know which way we're going. I don't want to ever trick you on that. I think science did a horrible job with the pH scale and understanding it that way. So acidity, increasing acidity, which means increasing hydrogen ion concentrations around the cells, also contributes to unloading O2 from hemoglobin. Yes?
So the answer choice you just gave, you said you'll have something in parentheses. I'm confused on which one it will be now. It will still be whichever one says increasing.
I want the one in parentheses. The science is screwed up. So if you say decrease, if it says decrease pH, I put alkalosis. That's what I want you to know. So that means becoming more alkaline versus becoming more acidic. Because decrease, when you think of decrease, you think the number's going down, don't you? When we decrease the amount of money we have, it's going down.
Yep.
And on the pH scale, it's opposite. I don't even like that. So use what I put in parentheses as your cue, whether it's becoming more acidic, I put acidosis.
or becoming more alkaline, it's alkalosis. Is that clear? And acidosis contributes to unloading oxygen. Down at the tissue, you guys need a break? It's been 50 minutes.
Sure.
You guys need a break, or want me to just keep plowing? Yeah, take 3 or 4 minute break, come back, no fight.